Now suppose you're given a surface as z equals the function of x and y, and you're being asked to find the normal line. What do you do? Well, we want to make use of the fact that gradient of a function is perpendicular to level surfaces. The problem is we're presented with the surface without any reference to the function whose level surface is this. And the way you make this into a level surface is, there are many ways, but the easiest one is to just simply subtract z and write it as this function. And if you define this function here as capital F of x, y, z, then indeed this curve would be the level surface f equal to 0. See, what's a level surface? If you have a multivariable function of 3-variable function. Okay, let me say that again. If you have a function of 3 variables and you set it equals to constant, then that gives you a level surface. So indeed this is a level surface. And that's nice because now all I have to calculate is the gradient of this function at 1, negative 1, 3. And that's desirable because I need a normal line, which means the direction of this line would be perpendicular to the surface. That means once I get the gradient of f, I can use it as a direction vector for the line. And since the line also passes through 1, negative 1, 3, then I can write down the equation for the line easily. Alright, so let's continue. Gradient of f is you differentiate by x, differentiate by y, differentiate by z. That's the definition of a gradient. If you take this and differentiate by x, all the other ones are treated as constant, so x squared differentiates to 2x. If you differentiate by y, all the other ones are treated constant. The only thing that's not a constant is y squared. That differentiates to 2y. And then if you differentiate by z, x and y are considered as constant. The only thing that's not constant is negative z. So if you differentiate negative z, that's negative 1. Which means gradient of f evaluated at 1, negative 1, 3. This means that x is 1 and y is negative 1 and z is 3. And since x is 1, you get 2 times 1. Since y is negative 1, you get 2 times negative 1. And here you don't see anything. It's not z, it's just negative 1. So it's just negative 1. So in the end, z equals to 3 doesn't get used at all. But sometimes that happens. Actually, if you start with z equals to a function, you will always see that z doesn't get used. But if you have other complex functions f, then you will have the case when you use the z. Alright, anyways, you get 2, negative 2, negative 1. That's our direction of the line. Because the line is normal to the surface. See, this vector is normal to the surface, and therefore to make the line normal to the surface, I need this to be our direction. So that means our line equation should be, it should start at 1, negative 1, 3, and then you should multiply by t the direction vector 2, negative 2, negative 1, and that's it. So this will be a line equation whose direction is 2, negative 2, negative 1. You can write your answer like this as a vector valued function, or you can multiply by t and rewrite it as 1 plus 2t, negative 1 minus 2t, and then 3 minus t. Or you can write this as in parametric form as x equals to 1 plus 2t, y as negative 1 minus 2t, and z as 3 minus t, which is called a parametric form. So this is called vector valued function form. And this one is called parametric form. And finally, if you differentiate these, if you solve these for t, that's x minus 1 over 2 is t, and y plus 1 over negative 2 is t, and z minus 3 divided by negative 1. All of these are t's, so this much is what we call the symmetric form. All three are called line equations, and unless the question specifies, some questions might say, find the equation of the normal line in symmetric form, blah, blah, blah. In that case, you would use this. But unless it's explicitly stated it wants one of the three, you can use either one of these three, and it should be regarded as correct.